Today is all about phase changes. So if you did the notes, you should know that going from a solid to a liquid is melting. Going from a liquid to a solid is freezing. Going from a liquid to a gas is vaporization. Going from a gas to a liquid is condensation. Going from a solid to a gas is sublimation. And going from a gas to a solid is deposition. Question 2 asks, does the temperature of a substance change when a substance changes phases? Why? I think yes, there's a certain amount of energy needed for each of the phase changes to occur, and heat produces the energy that is needed for that. So for example, if you want to go from a solid to a liquid, the heat energy has to increase, but so does the temperature in order to melt, because we know that's how you go from a solid to a liquid. Number 3, when does the temperature change in this diagram and why? So now we can look at our diagrams, and we can see that the temperature increases as the heat energy increases in order to maintain the shape. So if you're going from once again, a solid to a liquid, the heat and temperature must both increase. So an example of this would be like ice water, which is a heterogeneous mixture with two different phases. There's a solid and a liquid, but the temperature of it overall isn't going to be very warm. It's going to be relatively cold due to the ice, which is frozen water. The next page, we have a graph. So question 4, after you read that, of course, asks what variables are plotted on the phase diagram. And I said that I can see variables A, B, C, and D. A is near the triple point, B is towards the bottom, C is at the critical point, and D is close to the critical pressure. How many phases of water are represented in this phase diagram, and what are they? So I can see there's solid, liquid, and gas, and there's also freezing points and boiling points. So now we're looking at a table. So it says use this phase diagram for water to complete the following table. So for the first one, the temperature is at 200 degrees and the pressure is at 1. So you find that on the graph and we can see that that's at a boiling point. Now the temperature is at -2 and the pressure is 1, and we can see that's around freezing. The temperature is at 150 degrees and the pressure is at 100 now. So we see that is closer to a critical point in pressure. The next one, the temperature is at 50 and the pressure is 1. So that's a liquid. And the temperature is at 100 for the next one. And the pressure, and then we know it's a vapor. So we can look on our chart and we can see that vapor is at about 0.0060. Question 7, what phases of water coexist at each point along the horizontal curve? So now we look at the horizontal curve on the chart and we see there's a triple point, a normal boiling point, and a critical point, which is what we need. And then what two phases occur at each point at the vertical curve? So now we find the line going vertical, which is triple point, normal freezing point, and then there's variable D. At which pressure and temperature do the solid, liquid, and gaseous phases of water coexist? So we want to know where the solid, liquid, and gases can all be formed. And I came up with the temperature is at 100 and the pressure is at 1.00 around the normal boiling point. Turn the page, so now it's about energy, and this is on page 516 through 518 of your textbook. So the first question is, what is energy and how is it measured? I found that energy was the ability to do work or produce heat, and it's also measured in joules. Then it gives you an example. So the example says a package of Nutter Butter bites contain 130 nutritional calories, and you're supposed to convert that to calories. and then to joules. So then you create your next, after you solve that one, create another example. And I put, if you eat 4 cups of cereal, it's 260 nutritional calories, and you're supposed to convert into energy calories and then convert it to joules, and then relate it back to the first example. The next question are the types of energy, and I think there's chemical potential energy, chemical kinetic energy, and then there's heat energy. The next question says, describe the differences between chemical potential and chemical kinetic energy. So chemical potential energy is like the amount of stored energy in a substance. Chemical kinetic energy is like the rates of chemical in a process, I guess. The first law is between the heat and other energy, such as mechanical, electrical, and by extension of relationships, is measured. So you're trying to find the amount between the heat energy and also that like mechanical energy of a substance. What is temperature? Temperature is like the heat or pressure of a substance or in a substance. An example is like, we can use the steel spheres as one because you can measure like the mechanical energy as it's being pushed compared to like the amount of heat is needed to heat it up. The next page is calorimetry, which is page 519 through 526. So heat capacity is how much heat can be held like in an object before it changes phases, is what I think. Specific heat is like the heat required to raise the temperature of a specific object. In the equations, it says to memorize this. So the specific heat of a liquid water is 4.184 joules over grams times degrees Celsius. So the equation is Q equals C times M times, and then the little triangle T. So the little triangle T is the change in temperature. The C is the specific heat. The M is mass in grams. The Q is absorbed or released heat. So you're going to want to memorize that. The system is like the specific part of the universe. Surroundings is everything inside the universe except for the system. The universe is the system and surrounding, which is also important to know. There are some examples below, so you should try those with the equation. I will do one of those also, but we're going to go to the real world examples, which is like non-popping balloons. You can know how much heat is needed to pop it without burning it. Okay, so now if we're going to go to the example, let's just do this first one. So we know from this equation, we want to find the change in temperature. So the change in temperature for this one would be about this part right here. Times mass in grams. So we can see there's grams here and here. So I believe this is the mass, 500 grams of water. And we also want to know the specific heat. So I think we can find that by subtracting 29.24 minus 25.00. And then the Q is the absorbed or released heat. So I think that's what we're looking for. So keep that in mind. So now we're going to multiply the C times the M times the T. So the specific heat times 500 times the change in temperature, which is the number between these two. So that's a start. So go ahead and try to finish that one. And that's it.